and today we're going to be talking about misleading statistics. Let's jump in. All right, so let's start by talking about a definition of misleading data displays. So if you want, you can follow along as I read this. So let's get started. Graphs can be used to present, persuade, or even mislead the viewer. And unfortunately, this happens more often than you think. The same set of data can be presented on a graph in different ways. Sometimes the way that a graph is drawn can present only one side of the statistics. Now, why would this happen? Well, sometimes companies try to sell more of a specific product by creating misleading graphs. And you've probably seen this quite often. These graphs can be divided to make it look like a product is more popular than another product. Companies can also do this with purchases by showing that a percentage of people like their product better than another one. However, if you look at how the graph is divided and created, it'll give you an idea whether or not the statistics represented give a good overall picture of the data. So how can we identify misleading data? Well, one way is to show a break in the vertical axis. A break in the scale on the vertical axis will show more detail or emphasize an increase or decrease in data values. A break in the scale means that the vertical axis does not run straight up from 0 to the highest value. It breaks somewhere to keep a portion of the data from being obvious to the chart. And we'll look at some examples of this in just a minute. Using a different scale or spacing data along the horizontal or vertical axis will also change the appearance of the data. You may choose to space the values closely together to depict a greater change in the data, or you may choose to spread the values out to depict less of a change in the data. If you can't detect a change in the data, then it's misleading. So now let's look at an example. Here we go. Both of these graphs depict the average monthly water temperature in Hawaii. Which graph provides the most reliable view of the data? And if you need to pause the video to take a closer look, feel free. All right, so let's see what we've got here. Graph 2 shows a sharp increase in the change in water temperature. The change in temperature doesn't vary greatly from month to month. Therefore, graph 2 is not really a reliable display. Graph 1 reveals the change in water temperature as more gradual, and it's therefore a more reasonable indicator of the gradual temperature changes for which Hawaii is known. So you can see which one is more reliable and more accurate for all purposes. So when we're identifying and explaining misleading comparisons of data, we're looking for 3 things, and you might want to write these down in your notebook. Number 1, does the data show an accurate change from one piece of information to the next? Number 2, does the data start at 0, or is there a break in the vertical axis? And that's really an important one. And number 3, is the scale that's being used one that makes sense? And are the sections even or spread out too far? Let's look at another example. Explain why the data compared on the bar graph is misleading. And this has to do with shark attacks by state. And you can see Alabama, California, Florida, Georgia, Hawaii, and Texas. Now think about this for a minute. Why would you think that this would be misleading? Well, let's take a look at what it says here. While the rates of shark attacks are correct, you must take into consideration several things when you're analyzing the data. So first of all, each state on the graph has a different sized coastline, so that's going to be a factor. So for example, Florida's vast amount of coastline may contribute to the fact that it has a far higher incidence of shark attacks than any other U.S. state. As well, California, Florida, and Hawaii are all big beach destination states, and therefore the incidence of shark attacks will definitely be greater than states such as Alabama. So to make the data more reliable, a graph should be created comparing the incidence of shark attacks among states that are more geographically similar. Then it would be more reliable. All right, let's look at another example. The graph below compares the percentage of students that passed the California high school exit exam in 4 different counties in California. Explain why comparing the passing rates of these 4 counties is misleading. If you need to pause your video to take a closer look, feel free. You've got Imperial County, Los Angeles County, San Diego County, and Santa Barbara County. And I'll give you a hint. Look at the number of students as well. Okay, so let's see what we've got here. It says comparison of passing rates for these 4 counties is misleading because the number of students that took the CAISY in each county varies greatly. Imperial County had 100 students. LA County had 4,400. San Diego, 650. Santa Barbara, there's only 15 students there. So there's a very big difference in the number of students, which makes this not very reliable. Not reliable at all, in fact. So in order to make an accurate comparison, the number of students tested should be similar. The population of students might also be taken into consideration. You might ask, for example, do any of these students have learning disabilities? How many of the students speak English as their first language? These kinds of factors will influence results, and therefore one should be careful when you're comparing passing rates. So let's suppose that your task, that your job was to revise or to fix all the misleading data displays. How would you do that? Let's take a look at how you would do that. So there's 4 ways to make sure that your data display is not misleading. Number 1, you can ensure that the data is represented accurately if you begin that with the vertical axis scale at 0. That's an important one. You should also ensure that there's ample and equal space between the values on the horizontal and the vertical axis. And then choose a scale for the vertical axis that's not too large nor too small. And be sure that the things that you're comparing are similar, like what we didn't see in the last example. All right, let's look at one more example. The graph below depicts a sharp increase in panda population since 1976. Use the data to create another graph that depicts less of an increase in population and is more reliable. Go ahead and pause your video, take a look at this graph, and then see if you can do what the question is asking you to do. Okay, how'd you do? Does your graph look a little bit more like this? Here's how we would do this. Here's how we would create a graph that depicts less of an increase in the panda population. Number 1, you would allow for more space in between the years on the horizontal axis. That would be the first thing. Secondly, you'd increase the scale to 500 on the vertical axis and then plot the data points. So in 1976, we had 1,100, 1986, 900, 1996, 1,000, and 2006, 1,600 on the graph. All right, everyone, that just about does it for this lesson. Thanks for joining us, and we'll see you next time. Bye-bye.